All right, so what I'm going to do right now is go over the mission control interface. The idea here is to kind of show how an application could utilize it's having its own interfaces. So we have in libhow interfaces for generic hardware modules, and that's good and dandy. But they're going to have certain use cases where it makes more sense to potentially allow the developer who's using your application um, to implement a certain behavior in a certain way, the way that they may be interested in a more higher level way versus like looking at like the low level drivers like pins and ADCs and that kind of thing. So I'm going to show what that means and show what I'm going to show you what this means, and I'll kind of go into detail here. So in the robotics team, we have this thing called drive commands, and we have mode, speed, angle, wheel orientation is operational, and heartbeat counts. Heartbeat counts can be really important. Everything else is just what commands we use in order to control the state of the motors and the actuators, and to tell the drive system we know what to do. But this one tells us whether or not we're connected or whether or not we've gotten an update in a while, and this is going to be important. So here we have this class, mission control. We have a virtual. We have two virtual functions. One's a destructor, just to make sure that all implementations can call their parent destructor if there's any additional hierarchy in their inheritance hierarchy. And then we also have a get function. Now, I'm trying to think of a better name, and maybe the people who are on this call right now can come up with a better name. But right now, I just have get. And then I'm going to put in the private section, I am going to call, I'm going to do driver get. It doesn't have to say be driver. It can be impl jet. Actually, I'll just do impl. Impl get. So this is the implementation of get. I'm actually going to remove the virtual from here, and I'm going to have this function return impl get. Okay. Now, this is using libhow, so we could have done something like this. Something like that. I actually don't want us to do that because I want the code here to actually to be infallible, basically. I don't like the idea of our mission control interface being fallible, so we're actually going to keep that off, and you're going to see what I mean in a little bit. So we have our structure, the thing we want to return back. We have a getter function to get the current drive commands. Actually, I can probably call this thing current. I don't know if that even makes sense. Yeah, maybe actually let's do get command. Let's do that. That just kind of makes more sense. All right, so we have this get command here. Now, why are we even doing this? Well, in the future, the robotics team may change how they communicate. Well, let's say, right now they currently use the ESP8266 with its AT commands and stuff like that. In the future, they may move over to the ESP32. And I think the AT commands aren't that much different, but they might be a little bit different. So you're going to have to implement them a little differently. What if the club decides to communicate over LoRa or some type of XB or Zigbee communication, or NRF going over 2.4 gigahertz? That's not Wi-Fi, not Bluetooth. Or maybe you do use Bluetooth. Or maybe we just use Morse code with the digital pin and a timer. Who knows? But basically, this makes it such that so long as the commands don't change, or don't change much, this mission control interface can be used with any one of our different applications. We have a generic application that can control a Mars rover, specifically the drive system. This allows us to make a requirement for those who want to work with us. We don't care how you get your command data, but you send us command data and we will do our work. So let's kind of go into some of the things about this interface. So here, and the people who are on the call, Corey and Viha, you guys can, if you have any questions at any point in time, or any realizations at any time, you guys can bring them up. You could talk like normal. I just kind of did a little intro there to make sure that there was, it kind of, I did a little bit of intro there, just that it's a little more understandable.
Sounds good.
Cool. All right, so here's the idea. I'm actually just going to do, get the command object. This command will always return the last known value of the drive commands. At initialization, I should say initialization. Let's see. this command is infallible and will always return actually, let's put this to the front. Since infallible will always return a command. If mission control is disconnected from the rover or from the machine, this command will return the last known value. The heartbeat count can be used to indicate when the connection has been re-established. It is the responsibility of this driver to, how am I spelling this wrong? Oh, is it two L's? Oh, interesting. Cool. So, when the connection has been can be used to indicate when the connection has been reestablished. Your responsibility of establishing that connection is on this driver. This driver is allowed to utilize time during yeah, it's allowed to, let's see, what is the best, you know what, I need to add one more thing into this interface. So now that I'm thinking about it, as I'm writing it out, so please tell me if I'm following along. So here's the idea before I go into what I just realized. The idea is that every time you run git command, it'll always send you back a command. You're going to have to use heartbeat count in order to know if you've gotten too many heartbeats that are basically all the same. And you should be able to, inside your code, have a timer that can tell you between one time to another time. So you can know, oh, the heartbeat has not changed for about, you know, like 10 seconds, or 10 seconds is kind of long, for about 3 or 5 seconds. If that ever happens, we can just assume that we have not got an update for whatever reason. We don't need to worry about what that means so much, as whenever that happens, we simply override the drive command in the whole sequence in the rules engine. So the rules engine takes this information and will do its stuff in order to figure out what to do. It should then stop the rover at that point and then basically hold the rover as stopped until the heartbeat count begins to increment again. Then it can go back into following the instructions from the drive command. That's why keeping this consistent and keeping this constant can be an indication to the application, the drive system's application, that something has gone wrong, or something has basically paused, or we haven't gotten any updates in a while. Does that make sense so far?
Yeah.
Now this other part here is it is the responsibility of this driver to reestablish the connection. So every time, and the idea I have here is that, like I was going to say, like every time you call get command, it is its responsibility during that time to come up with a way to figure out how should I say this? Basically, come up with a way to figure out how do we connect. So basically, with the so I made some changes to the ESP library. I believe I simplified it. You can tell me if you don't believe so, if it doesn't feel that way. But I didn't say that. I'm for sure simplified it. The previous way, I did it because I wanted it to be very, very safe, but ended up making it more difficult to work with. So you create it. This just resets it for the most part. Then you can connect to an access point. Then you connect to a server, and then you write to the server, and you read from the server. That's about it. These are all one object. You don't have to do that like double creation thing where you create the wireless LAN object and then create the socket object. Those are not a thing. You can read whenever you want. You can write whenever you want. There are some preconditions, like if you want to actually read and write, you need to have a server that you're connected to. Otherwise, the system will just return back an error. But what you can basically do, if you use the ESP, is when you do a command and you try to write, make a request and then get the information back. if you don't get anything back or you get like an error back, rather than like, restart the entire program, which could take time, you could simply see, okay, well, we got an error back, return back the previous value, and then mark ourselves as unconnected, and then try to reconnect again. So go through the reconnection process. And every time you get command called, you'll attempt that again, because it does take some time to do that. Now, the thing that I'm realizing is that I was going to put here, the driver is allowed to utilize time during this call in order to re-establish the connection. The idea here is that rather than rather than having another thread that tries to reestablish the connection, what you do here is you simply use the call to this function as a way to stimulate and to make progress towards that. Now, the only thing though is that the amount of time that you're given should be not like infinite. Yeah, it would be kind of unfortunate for this to be infinite. So I'm going to take a how function ref. I need to actually include the how function ref. So let's actually do this. Include lib how timeout. Wait, not timeout. Was it timeout? I think it is. Yeah, so let's then do, why can't I ever remember? Let's go into ESP here, actually. Yeah, it's a how timeout function. So we're going to take a timeout function. Using a function ref basically means that you can pass in a function of any type, or I wouldn't say function. You can pass in a callable of any type, functor, a lambda, or something else, or just a normal function. So we can take that in, and we're just going to call this timeout. And we're going to have to make sure that the virtual function also has the same thing. Okay. We got to make sure we pass that along. Okay. So now what happens is whenever you do get command, you have a timeout. And the thing is, whenever that timeout exceeds, which we should actually put that down here, the timeout is used to break out of the function to break out of the function. Is used to break out of the function. This is useful because attempting to re-establish a connection to mission control could take a considerable amount of time and thus could stall out the application.
Yeah, so pretty much if we take too much time, we just want to completely reset the application itself.
Well, no, actually, in this case, the idea is you give it a certain amount of time, and rather than reset, you just simply return back the original drive command. So the application can keep running and keep checking the heartbeat sensor and then stop. Because we're not in a position where we need to reset. Reset, I believe, is really important when you hit some sort of when you seg fault or something like that. Resetting should be or you had an unexpected error that you don't know how to recover from. That's why you do how check all the way up to the top. That way, rather than having a supporting condition for every single possible thing that can go wrong, you support the things that you know are going to go wrong, that you have a good way to support. Everything else should just cause it to reset, because there's something wrong with the whole system if, let's say you try to create the CAN driver and that messes up. The code should just kind of reset itself and not progress any further. Because one, you can't fix that. That's a bug. Someone wrote a bug into the application. Or the library that you're using somehow is broken. Like there's a bug in my application, which gets you can't get around that, and you're really early enough to the point where you can just reset loop yourself and it not cause any issues. Does that make sense?
Yeah. Additionally, we'd probably set the speed to 0 if this happened. Just so
yes, 100%. Yeah, you set the angle and speed to 0, and then you let it do its thing, and then you
definitely.
wait. Yeah.
Sounds good.
Yeah. So the timeout is used to break out the function. So you can give it I only want to attempt to get the command and let it do work. Because we're doing the same thing. I'm going to give you this much amount of time to actually try to reestablish a connection if you have a connection issue. If there isn't, it can do its thing, blah, 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 come back, and then you get your information. Now, each time you call this, each call from this function need not, how should I put this? How should I say this? What I want to say is that the get function, so the get function should do the work of actually reaching out to the server and then getting a response back. Versus, again, trying to have another thread for this. I don't think a thread's required. This function, this, I'm not going to put that in there. I don't think that's required. People can implement it however they like. But you could use another thread for this, but I kind of wanted to indicate that a thread's not really required for this to work. But yeah, so okay. So that's pretty much the idea of the interface is, let's actually do, let's try this and see. Yeah, they put it right next to each other, okay. Okay. Check my Discord real quick, make sure everything's okay. Is that from robotics? Oh, it's on the mechanical, okay. Cool. All right, so the amount of time to either get the latest command or attempt to re-establish a connection to mission control. The last known drive command received if, I always get that mixed up. If no commands have been received, then this should return the default initialized drive command. Okay. Someone's unironically playing that song. That's hilarious. I wish I remember the name of the song though. Okay, so that's the idea. With this, your rules engine should be able to do literally everything and just call this function without having to worry about errors and just kind of go from there. And then this allows us to strip out all of the implementation details and put them in here. So you can basically have one person dedicated towards building out the implementation and fixing problems on that side while making sure that your application is nice and safe. That way, what happens is we're actually going to write something. Let's say we have HAL status application. We're going to make the application just a function, And we have our SJSU hardware map, right? So we pass in our hardware map, pmap. And this will now, the new one will now just include motors and servos. And that's about it. I don't think you guys need anything else, right? Yeah, motors and servos, that's it. Then you'll take a mission control interface and then just call it, mission control. And then from here, because this will incorporate, actually, so let's make that real quick. Let's just I want to show this off, make sure you guys, space, SJSU, struct, hardware map, and then let's see, what am I gonna do? Yeah, so HAL motor, let's add that up here too. And then we're gonna do servo. Yeah, actually, and then I'm also going to include span. Now this part here, is going to be extra effort for Corey, but I think that it's a really good thing for us to do. And I think Corey's excited about that too, actually. So
always
propulsion. So we have our propulsion motors. We have our steering. And then, is there anything else that we need? I think that's pretty much it, right? We just need a set of propulsion and steering motors, right?
Yeah, we have magnets, but that's besides the point. It's arbitrary.
Oh, the magnets. No, those are important. I'm trying to think of what we do with those actually, because I feel like this is something where oh man, how do you handle the magnets? Oh, you know what? You don't. You do not. You don't. Yeah, magnets are not important here. I'll explain in a little bit. Good for bringing that up though, because now I can explain it in this video, and we can have this as we can have this for later. So I can actually do this as a stood pair, and make this motor and servo. Because I realized, actually, can you guys figure out why I'm doing this? Why I'm making them a pair?
Give me a second. Let me think.
Okay.
I mean, this may be too obvious, but it's because they are an actual pair. Like you never have one without the other in the drive system. Like that's what makes up a leg pretty much.
Beautiful. Exactly. So in a way, I kind of just did this. I did this for a couple things, but like, let's call this leg, leg combo. Yeah. So we almost always have the both. I don't think we're gonna support like having a mixed set where you have servos by themselves and the motors by themselves. But the idea here is that like I realized when I make those two spans that we have to check to make sure that they're bigger. Both spans are bigger than two like because we don't support two-legged robots at the moment. We support three and above. The other thing is to make sure that the sizes between them are also equal. So we have to check servo, check motor, and then check that they're both equal. We can eliminate even having to check both of them by simply putting them in a pair. Now all we have to do is make sure that this one, we remove three conditionals that then become just one. Is this leg combo or leg, is it above two? If it is, that's it. So something to keep in mind whenever you're developing something, like, when you see that there's like extra stuff or things where you might have to do more conditionals to test it, like, oh, I got to add more and more code to test, every single combination for this. Actually, I think doing more unit tests, because it's so time consuming, will also help you to write more efficient code. I don't think that's generally the case, but I think in a lot of cases, the more knowing your unit test is, potentially the more complex your code is, and maybe there's a way to make it less complex. And I'm actually going to go even further. Rather than making this a pair, I'm actually making this another struct, because I firmly believe that I think that drive leg, that we can make it a pair, but I think but pairs are a little bit like, I think a little hard to reason about, So I'm just going to say this one is steering. This one is propulsion. Beautiful. Now I'm just going to make a span of those. And now people have to make an array of these and then give that array to this. And that's how they then determine like how many legs you have. So now you can put like 3, 4, 5, which would be weird, 6 legs for your robot. Okay, so everything seeming good at this point?
Yeah.
Cool. So now, and you're probably wondering to yourself, well, our servos aren't homed. They don't know where they currently are. So how do we handle, that? And that's where we come up with something that we spoke about, me and you, Corey, a while back, which is that we need an offset servo that basically takes your servo and adds an offset to it. And then you can pass that as another servo object. So it looks something like this. I can I could probably write this out right now and then have one of you guys bring it into libhowsoft. It's really easy. So we're actually going to implement public hal servo. Okay, let's actually put public here too, because we need to make a create function. This guy holds a hal servo inside of itself. And that looks kind of weird and wonky, but it's gonna make sense. So we're gonna do hal result offset servo. This will return. We're gonna do a create function. We're gonna create a factory, and this factory simply takes a servo reference. And then I'm going to also create a constructor for offset servo that does something very simple. And then take this, copy that, put that there. Oopsie daisy.
So this is just going to implement the HAL servo interface, right? So it's just going to pretty much add the homing offset to the set every single time.
Correct. So the idea here is, oh my goodness, I put M up here. That's so silly. Did I put M up there? No, I did not. Let's put Oh wait, yeah, I just have to fuck up here. But yeah, no. So the idea is that like you have your RMD motor, and what you're gonna do is you can then use make servo out of it in order to turn it into a servo. Then from there, what you can then do is pass that into offset servo. So basically, before you even pass it to offset servo, which you might maybe have an API allow you to change the offset whenever you need to. Actually, that seems okay. Yeah, why not? But the idea is that what you can do is you can start controlling the motor and moving it into the right spot until you hit the tick. Once you hit that, you know from where you started what you consider zero. Move it to zero, then you start moving until eventually you hit the actual thing. Then you can calculate the angle that you made, or you can even get the feedback back to get what the angle difference is. Pass that into offset servo to offset it, and now you just have a servo that that has the appropriate angle, where it's 0 is where you want it to be, and then you can have your rest of your code do the rest of the work, and you can have it as part of like the guidelines for when you describe the hardware map and like how the servo's angle should be for the hardware map. We have documentation here explaining like describing the homed angle of the servo.
And the beautiful part about this is that it implements error interface, right? So now we don't have to pass in the offset servo. We can pass in the servo. We can pass in the offset servo if we wanted, and so we don't even have to do homing in this case.
Yes, you do a homing in a separate step, get that, and then now your application does not have to worry about it. It assumes when you give it its servo, the servos are already in the appropriate place.
Yeah, it doesn't even have to assume that. It just assumes that, oh, I'm still just going to 0. I'm going to my 0, though. Like, you just defined it differently because Correct. I just redefined it. So it's completely arbitrary or abstracted away from it now. So that's really interesting.
Yes. Now, the thing I want to say about the home angle is that, like, we do need to describe what that means so that there's some logic for application. Let's say you wanted someone else to use this. Angle 0 degrees of the steering servo must be perpendicular to the to the leg. Oh man, I'm trying to think.
So
with the 3 wheels,
I would say that it can be any home as long as the wheels are all at home. They're all perpendicular to each other. Right? Perpendicular or parallel with each other.
Gotcha. Okay, so the idea is perpendicular to each other or parallel. Now,
perpendicular is, hold on, I'm messing up on words. Perpendicular. No, parallel.
Parallel?
Yeah. I don't know why I was forgetting that.
Are they, on the 3-wheel configuration, are they parallel? Like, I mean, like, they're all like making
in
the
drive
triangle.
mode? Yes.
Oh, got you. Wait, hold on, but do we
except when you're turning, but at home, they shouldn't be turning at all. So parallel, every single wheel parallel to each other is home.
Wait, hold on. Oh, okay. So the idea here is so when you do home, okay, so I get it. Okay, you actually, I think that's even better than what I was thinking. You're right. Because in my case, I was like, if all of them are perpendicular, I'm thinking about like where you place the sensor, you know, like where you place your sensors. But you're saying, no, screw that noise. Don't even worry about where the sensors are. That's just for us to figure out where we are. Then from there, you go forward and you should get into a forward position. Yeah, I like that.
Exactly.
Angle 0 degree. For the steering servo must be of all steering servos. Means that the servos are parallel with each other and facing forward relative to the rover's front. The front could be anywhere. Yeah. The front of the rover is at the I don't know if discretion is the right word. It's a choice made by the engineers, by the developers. Okay. With the steering motor, steering servos facing 0 degrees. All propulsion motors, when actuated beyond 0% power, should go forward. Actually, when all propulsion motors, when actuated beyond power, actually, let's do this. Closer to 0. All propulsion motors, when actuated with a positive percentage of power, should go forward, and with a negative power percentage should go backwards. That way, now we have a very clear-cut definition on how you need to provide these like we come up with a specification for what you need to give us for us to do our work. That make sense? You guys
Yes.
Okay, cool. Viha?
Yeah.
Cool. Okay, give me one sec. Sorry, someone's smoking outside, and I've been trying to find them for a while, but haven't had any luck. Right now, I want to finish this meeting. Oh, no, my room smells like smoke. Fuck. All right, so.
Fantastic.
Yeah, I know, it's awful. All right, so put a little ampersand here. All right, so that should give us the M servo. Now we need to implement some of these things. So let's do. I forget. I always forgot how it's written. Let's go down here. Position. Oh, and I need to show me the offset. How degrees. M offset. And I can make the offset here. M 0. Do this. Actually, make that private. And then override how result. I think position type is empty. Yes, it is. Okay. And then all you have to do is do mservo.position is equal to, oh my God, does this say power? Oh, I gotta that's a typo. That should be position. Whoopsie daisy. I'll go fix that like today. I don't know if that's not even an API break. Yeah, that's just, yeah. Yeah, so we do this. Put in position plus M offset, and we're done. Now we need a way to update the offset. So let's just do void M offset. Sorry, I don't know why I'm thinking that. Offset, how degrees new offset. And then just set this offset to equal to new offset. Now we could, like, you might be thinking to yourself, like, do we do like some type of like, why don't we return status or something like that? Nah, I don't think it's well, we can also probably even gather out we should be able to, like, you know, return back the offset too, so that'd be useful. I don't know if we totally use it, but I don't see a reason why not to support it if someone does want. I forget what the previous offset was. Okay. Oops, daisy. This isn't Rust. All right, so yeah, so that's that. So now you can set your offset. You create the object, and then you can set your offset. The offset gets defaulted to 0. I could explain that in the comments here, but I'm not gonna. We can do that later. Oh, and we still need to create this guy. So this guy has no problem being created, so we're not going to put anything there. But there could be in the future where we actually do care about what we pass in and that kind of thing, and, like, you know, do some type of checks here and stuff like that. So that's the thing. But yeah, so that's pretty much it. This is the whole implementation for offset servo. The idea is that, yeah, we can home it ourselves, and then, you know, create and then do what we need to do in order to give the appropriate offset to make it all forward. that step would happen before you even call the application. This is like the pre-application initialization stage. And then once you hit that point, then you run the application. The application does the rest for you. And that's the idea. And this is where I think the club would do really well going forward is having, actually let's make the whole namespace this. Oops, Daisy. We'll be in really good position if we do this because then, yeah, you get a lot of nice properties from this. Do you agree?
Sorry, I keep muting myself. Yeah, I agree. So the whole idea here, we've talked about this multiple times. We're adding another step into our application building is going to come somewhere, right? So we have our hardware map, which gets passed into the initializer, which then we go from our initializer into the application initializing. I don't know what to call it yet. Come up with a name for it, which is this stage where you're getting the offset and doing all that fun stuff. And then you go into your actual application control flow, which uses mission control interface plus your application and the control flow.
Yes. I will say that like the previous one, I know you didn't like try to keep that as a name, but like, yeah, no, I don't want to call the other one application. Like we have initialized target, or target initializer or whatever one, like, you know, people like, sounds better. Let's say we have initialized target. Like maybe like or like I guess we need to change the initialized target. Initialized platform. Thank you. So we can probably just think about it like from the platform level. So.
Yeah, that's right. Because we switched the terminology of that, didn't we?
Yes, we did.
Okay. Yeah.
And I guess this would be like pre-init application or initialized application. Maybe it's just initialized application. Then you pass that set of stuff because you can like pass the stuff from the hardware map from your platform into your initializer. And the cool thing is that like you can basically swap out how should I put this? The application is agnostic. It doesn't care what you're doing it with. So you might need an entirely different application depending on what you're trying to build. But the cool thing is that you can take that same drive logic and apply it anywhere. But you could definitely have very widely different initialized platform, initialized application stuff. I mean, maybe even initialized platform has all that other details inside of it. The first stage is gathering all the different drivers, and the second stage is basically doing the initialization stuff. Now you can put that into another function, so it's not like super like one big long thing, but you get all that set up and all that done, and then from there, you then can put it into the application. The application takes the rest.
Okay.
Yeah. Yeah, and you can separate them out into separate like packages. Then we can start going into how we package these things, how we version control it, and then we can like quite nicely, like if you ever needed to, you could like revert back the application layer and keep the rest the same. Or if you even want to as well, well, I don't know if making a package that delivers on the first stage makes sense. But we could potentially do that. That could be a thing. But there's a lot of ways we can kind of spin this to make this like even more modular, which will just make it easier for us to switch to anything else if it comes its way.
Yeah. I'd like to think more into that, honestly.
Yeah. So
fun stuff.
Yeah. Any questions on this? Anything we feel like we haven't gone over or haven't like kind of fleshed out?
Scroll down, just slowly. Pretty, no, all looks good. Go all the way down to the bottom. And so, okay, driver position, drive leg. Okay, yeah, this makes sense.
Cool. I think the one thing that I don't like about this, about the hardware map, is the fact that one thing that I am kind of that I don't like using pointers in this particular case. I like them for objects because if you use a reference, it has some implications. Basically, it removes your copy constructor and your move constructor. I think your copy constructor works. Your move constructor does not work, which sucks because it gets in the way a lot of times when you want to like return an object or something like that. But here, I'm looking about this. We get a copy constructor, which would be fine. We can copy these objects around, but moving it Not sure if we need that. The reason I bring this up is because it'd be really nice if we made these references, because it would actually force you to set them. You would have to set them. You wouldn't be allowed to not set them. But I don't know if this is the right way going forward. I think, because if you set these to null pointer, that could be problematic. And I don't know if we want the application to, we have two options here. If we keep them as pointers. The application checks and then returns back an error if they're invalid. Or B, they say that it's a precondition that these things are already set to valid objects. And if they are not, undefined behavior happens. So you can either say, hey, it's on the programmer to do this right, or you can, it's on the programmer. It is on us to check. Or 3, we put references here, but then it makes it harder to use because you might be in a situation where you may want to copy it or move it. Actually, this would be problematic the moment you want to use this for, if you want to do HAL, let's do this. Let's say you have like HAL, SJSU, hardware map, and get map or something like that. You have some function that returns this. Well, if you do result, you'd have to keep it inside result, because you could not move it beyond that point. Like, you couldn't get it out of that object. Actually, no. Is that a copy? No, maybe it makes a copy. I'll have to check. Yeah, actually, yeah, it gets a little complicated. Yeah. So, just a thought. Right now, I can stay as pointers. But, yeah, that's the idea. Any last comments or questions?
No, and I don't think keeping it as a pointer is necessarily bad. I think having a requirement from the user doesn't make it isn't necessarily an awful thing. You just have to say that there's a requirement and specify it, right?
Mm-hmm, yeah. Ooh, I just thought about something else, actually. So...
Actually,
yeah, go for it. Yeah.
So, okay, maybe I'm not understanding everything right, but so you said initially what we want to do is in the future, if you want to like change the way we interact with, so like Wi-Fi,
Mm-hmm.
How does this interface like help us like make it modular?
Mm-hmm.
I'm confused because like we don't ever put in like a spot for like overusing ESP, overusing something else. You know?
Mm-hmm. Yeah.
Does that make sense?
Yeah. So what you would do is somewhere down here or somewhere here, you would go, all right, so let's say you're in charge of doing ESP support because we want to use the ESP for communication with our mesh controller server. So what we do first is we create a class called ESP8266 mesh control. Let's do class. We're going to inherit the mission control interface. And then we're going to implement this function here to do all the work we want it to do.
Yes. And the reason why we don't see us kind of differentiating between the two is because it's completely different applications. We have one application built for ESP and one application built for serial. And so we just compile those separately. And so if we do it this way, then we'll have the ability to just pass in and out super quickly rather than copy pasting code, which is what we were doing previously, to switch it out, or just build 2 at a time pretty much, which is not ideal. This makes it much just better programming practice as well.
Yeah, actually, yeah, it makes a lot more sense. Okay, I get it.
Cool. Was I?
Yeah,
was
you're
right
on the money. 100% on the money. Yep, that's it.
Okay.
I'm actually just gonna do HAL result create, and then you have to fill this part out, and then yeah, you fill this part out, and then yeah. So yeah, that's pretty much the idea. You implement one of these, and then let's say in the future we're like, well, we're doing this, but we want to use this, we want to do something with testing, but like getting the whole ESP set up is just kind of a whole big thing. What if we just use serial? So you could do another one of these just for like serial USB. And then go from there. And then you can then we can keep extending this as many times as we want. And then once we have the object created, we can just pass it into this point because it can represent its parent, and then we're good to go.
Okay.
Cool.
Yeah, that makes sense to me though.
Cool. There's another thing that I thought about. Actually, no, that's actually, no, we're fine there. No, we don't have to worry about that. one idea that I had, and this would make your lives a little easier. So like the cool thing about this whole thing, if we actually keep them as pointers, actually no, it doesn't matter if they were pointers or references, but actually, yeah, you know what? No, this has to be on the developer side, not on the application side. The application should be doing this extra work because it just ends up making its footprint bigger, which isn't really helpful for the application. Because if it wants to, look good on any size system, it should be able to work on anything and shouldn't try to do extra work it doesn't need to. So the cool thing about, what I was thinking about was, maybe you could use the null pointer of the motor to indicate that the motor is inactive. A couple problems with this though. If you use a pointer in this way, basically you'd have to check the value of the, you have to check every single time in your code, hey, is this motor null pointer or not? And you might think, okay, well, what if you get past a certain point? Well, your code would never know if the motor is always valid. So you always have to check. So that's one annoyance. And all those additional checks end up making the code a lot bigger because now you have to compare every single time before you do any operation. You lose performance and you increase your code size. Does that make sense?
Mm-hmm.
Cool. Now, one thing you can do is let's say you want to disable a certain motor. Let's say it's not working or something just kind of up or something like that. Or you just want to see what happens when you remove it from the equation. What you can use is
yeah, I think you have a lot of background noise. Would you mind muting your mic?
Oh, yeah.
Thanks.
Where were we? Yeah. All right. So what you could actually do over here, and actually move that stuff up a little bit more so it's not in the way. But let's get rid of that. Let's put this over here, and then put right underneath the. All right, let's just do it there. And then hover map. Okay. Yeah, so one really cool benefit of using these here is that I can then create a HAL inert motor. Just do inert. And there's no parameters for that one. So does it even come back as a, it does come back as a result. Wait, yeah, that's fine, yeah. Dot value, just for now. But the main idea here is that you could actually have your code basically you could replace one of your motors or servos with an inert motor or servo, and the benefit is that that basically rather than initializing a whole actual servo, you just maybe have an if-def inside your code to replace one of them, or you just go in and copy just actually modify the code. But it makes swapping out or changing some of the motors easy. And then if you ever mess up the ordering of them, you could just reorder them. It's not it's deeply nested inside your logic to talk to each individual motor in a certain way. So this really gives you a lot more flexibility, in my opinion, to be able to remove away servos or remove away propulsion during testing. So yeah.
Okay, interesting.
Yeah. So the inert drivers are basically just drivers that do nothing. There is one for everything except for I think I2C, SPI, and UART because those ones have potential implications on what happens when you don't return back a expected value. So those ones are still something we want to workshop. But yeah, these other ones, they're all output driven. With ADC, you can just have back a constant value and you're good. But all the output driven ones, you can just drop the information and then the other system's is none the wiser because we don't do feedback. Because most systems you can't really get feedback. Like motor, you can't get feedback back. It's the whole point is that it's a non-feedback system. So yeah.
Okay, yeah, that makes sense.
Yep, so that's pretty much it. Any questions or comments on anything else you have here? Give yourself some time to think about it.
No, I think I'm good.
Via Vaha?
Yeah, I don't have any questions right now either.
All right, Via has spoken. Cool. Yeah. So I'm trying to think of where I should post this.
Maya.
Straight up came at the end. Oh wait, this is Maya though. Okay, cool.
GitHub.
It's just Maya.
I can't